Hello everyone. In this video, I'm going to be going over Hess's law. Um, Apologies in advance for my voice. Well, I guess not in advance because it's already happening, but apologies for my voice. I am suffering from a cold right now. I'm not really suffering. I'm recovering from a cold, so my voice is a little bit like congested sounding. So apologies for that if I sound really groggy and crappy during this video. That's why. Okay, so Hess's law. So what Hess's law basically is, and the problems that we're going to be seeing are problems where we're given a few chemical reactions and their enthalpies, and we have to find the enthalpy of a given reaction using the reactions that we were also given in the equation, right? So I have an example down here of kind of what that looks like in like simple terms. So say that we have something like A plus B yields C, and the change in enthalpy is 400. I gotta add something in here. And the change in H is 400 kilojoules per mole right here. And then down here, we have D plus E is equal to, or yields F. And then the change in enthalpy is going to be negative 20 kilograms per mole, right? So that's just an example. And then we have to find the change in enthalpy of B plus D yields C, right? So we can find that by taking B, getting D. We have to cancel some things and, do whatever we need to do in order to find this reaction here. So I'm going to go through two example problems. I don't have a really good practice problem. I tried to look through the textbook, but a lot of them were way too many things going on in them. So I'm going to go over the one that we did in class, and then I'm also going to do the one that is on this little unit 2 review problem. So I'm just going to go over those. I don't have any practice, but if you guys feel confident in them, go for it. Do them without, watching me do it first. So just to outline what I like to do with the Hess law problems. So with Hess laws, there's kind of different ways that you can go about them and you can get the same results. But what I personally like to do is I like to find what I need, right? So when my equation is find me the enthalpy of this equation, I'm like, okay, cool. So I'm going to need this thing, I'm going to need this thing, and I'm going to need this thing. All right, what can I do to make that happen? Do I have to reverse something? So you may have to reverse it. You may also have to scale, right? Which is in the next step where you have to scale up or down in order to get desired moles. In the first problem that I do, there's no scaling up or down. There's a lot of times where you don't have to scale anything and everything's already perfect with the moles and you just have to flip something and you're good to go. But with this, you have to remember that you want to get a singular equation, right? So you want to get to the equation that they're asking for. And whatever you do to the equations to get to that equation that you want, you have to change those enthalpies. And I'll show you that. I know that when I'm saying this is, you're probably like, what are you talking about? Like, this is confusing. It's a lot of words going on, and I understand. Um, so I'm going to be showing you that, and I'll explain it step by step, exactly how I do it, my thought process, everything like that, right? So you want to cancel things, so you have to scale up or down in order to get the desired moles, right? So let's say that you want to get rid of oxygen, but you have oxygen on this side, and then you have, let's say, 2 oxygens on this side. You can't cancel those, because if you cancel them, you're still left with an oxygen. So what you have to do is you have to get them to the same molarity, right? So you have to do, say we do 2 over 3 for this, right? So you can cancel the 3 and you're left with 2, and then you have to change the enthalpy to be 2 over 3 times the original enthalpy. And then you can cancel all those out, and then you're good, right? So I'll go through that. And then once you do that, you add the enthalpies of the manipulated chemical equations, and that's your answer. Your answer is the enthalpies added together of those manipulated chemical equations after you did what you needed to do in order to cancel things and get the original problem that you were asked for. Okay, so I'm going to first go over the easy example, and then we'll get into a little bit of a harder one, which was the one that we did in class, right? Okay, given that I rewrote the problem here a little bit because when I copied and pasted it, it turned out pretty goofy. So given N2 plus 2O2 yields 2NO2, and the delta H of that reaction is 66.4 kilojoules, and also that 2NO plus O2 yields 2NO2, and the change in enthalpy of that is negative 114.2 kilojoules. Estimate the delta H for N2 plus O2 yields, there's supposed to be a yield sign there. Again, like it didn't copy right. Yields 2NO. And it just says in here all of these are in the gas phase, which doesn't necessarily matter for us, right? So the first thing I'm going to do is I'm going to look at this equation and be like, all right, what do we need? All right, so I know that I need I need a N2, right, on the left side. So let's see. All right, so I know I have a N2 on this side. All right, and then I need O2 also on that same side. Okay, so I know I got it here, but I also have it here. So I have a feeling I'm going to go with this one just because these two are together, but we'll see, right? Let's see what the next thing we need. So we need 2NO on the right side. This isn't 2NO. It looks like it's close to 2NO, but no, this is 2NO2, so this is not what we need. So we're going to say, no, we don't want that. Oh, there it is. All right, cool. So this is what we need. So what we're going to do is we're going to have to flip this equation in order to get this to the right side, and then we're going to have to cancel some things out, and we'll see once we get to that step to see if we need to do anything, right? So the first thing that I always do is I always flip the stuff first, right? So I'm going to just take these and put them on this side and take this and put it on this side. So we're going to get 2NO2 will yield 2NO plus O2. And then I'm going to flip that enthalpy, flipping it by just making this positive, so we're multiplying it by -1 in order to flip it. So it's just going to be 114.2 kilojoules, because if we multiply this by -1, that's the answer that we'll get. This will become positive, right? Okay, so I think that's all good for now. We'll see in a little bit if we have to do any more manipulation, but for this equation, we can keep this one the exact same because we don't need to flip things or anything, right? So we're going to keep this one the same, and then we'll see what type of manipulation we have to do. Okay, so we have N2 plus 2O2 will yield 2NO2, and the change in enthalpy for now is going to stay 66.4 kilojoules. And the reason why I'm saying for now is because right now I don't know if I have to manipulate things, but let's get to canceling things, right? So I can already say off bat that I can cancel these two, right? So when you're making a chemical equation and you have two things on opposite sides, you can get rid of them, right? So if I have something like A plus C is yields D, and then I have A plus B yields C, I can get rid of the C's. I can't get rid of the A's. This would actually become like 2A plus B yields D. That would be like the overall equation because you can cancel these. Can't cancel the B because there's nothing cancel. Can't cancel the D, so the D is going to stay. This is going to be 2A because you're adding these together. But yeah, so that's what that looks like, and that's why we can do that, because that's like the rules of the chemical equations here. Okay, what else can we cancel? I don't want to cancel this, so that's good that we can't. I don't want to cancel this also. I do see that I can get rid of one of the O2s. So I can get rid of one O2 over here, and I can get rid of one over here then. So, cool. Let's see our results. So we get N2 plus O2 yields 2NO. And let's check with our equation that we wanted. Cool. We don't have to do anything else. We don't have to do any more manipulation. So all we have to do is add these two numbers together. I'm going to kind of do this in my head. I'm really bad at mental math, so let's see how this goes. I think that'll be a 0 there. That should be an 8, and that should be a 1. Let's check our answer. 180.6, that what we got? 180.6 kilojoules. Cool. So that would be our answer. We don't need this in our answer, but it's good to show the work. Like, personally, I like showing my work, but on a multiple choice test, it doesn't necessarily matter. But, you know, you could always go back and be like, this answer doesn't seem right. Let me check my work. So I always like to put my work, everything like that, right? Cool. So that's that one. Okay, now moving on to the more difficult question. This is the one that we did in class. It's more difficult because it has to do with scaling, and you're scaling with fractions, which can get really tough to look at. You're like, oh my god, what's going on? But yeah, so feel free to pause the video and try this out yourself if you're feeling confident after that problem. If not, this is a great one to go over because we have to do scaling and we have to flip things. So it's a good one to review all of the little aspects. Okay, so we have 2H2 plus O2 yields 2H2O. Hey, good old water. All right, then we got 3O2 yields 2O3. I think that's like, I think O3 is like ozone. I don't even know. Alexa, is ozone O3? I do this in every video. I'm so sorry.
From energyeducation.ca, ozone is a molecule of oxygen with the formula O3.
Yeah, it is. Look at me go. You know, you would think as a chem major I would just know that, but I had to check. Because it would be dumb if I like went on here and I was like, oh my god, that's ozone. And then somebody was like, no, it's not. It's literally not ozone. Like, that would be embarrassing. Okay. Anyways. So, looking at the equation that we need, it's 3H2 plus O3 yields H2O. Cool. What I can see right here from now is that the H2 is on the right side, meaning that's on the left side, so it's the correct side, I'll say, not the right side, because that's confusing. So H2 is on the correct side as of now, so I don't think I'm going to have to flip any equations, because there's no H2 over here. At least I don't have to flip this equation, and we also have the H2O on that side. Cool. I can just sit back, let that thing do its thing. I can tell that we're going to need to scale things, because the moles are different on the H2 and on the H2O, but it looks like it'll be an easy scale, because they're the same scale. And then we're looking here. So I want the O3. I don't want the O2. So that means I'm going to have to flip this equation. So I'm going to do that first. So I'm going to flip that equation first. So we're going to have 2O3 will yield 3O2. And then with that, I'm going to have to flip my enthalpy here, which would be for this equation. So we're going to have to just make that negative kilojoules per mole. Okay, and the next thing I want to do is I want to see if I need to scale this, right? So in this equation, I only want one ozone, but in this equation, I'm given, did I even flip it? Yeah, I did flip it, okay. Sorry, I was like, wait. So in this equation, I want one ozone, and this one I want two. So what I'm going to do, I'll do this in a different color so that's not confusing. I'm going to multiply this by 1/2, this whole thing by 1/2, which means I'm going to have to multiply this whole thing by 1/2, right? So our finishing equation here will be 103. You don't need to put the 1, but I'm going to put it there just so that I know that that's just 1. And then it's going to be 3/2, O2. And then the enthalpy, oh god, I'm going to need a calculator for that. We have 84.6 divided by 2. And we will get, change it to H, will be negative 142.3 kilojoules per mole. Okay, cool. Alrighty, so I think that that's good for that equation. We're gonna see how, oh, I'm gonna get a call from my boyfriend real quick. Let me do not disturb so you guys don't have to see that. So I think we're done with that equation. We'll see when we do the next one if we have to scale things to cancel it. If not, then we should be good. So let's see. Alright, so the next equation, we have the scaling that we have to do. We don't have to flip things, so let's go straight to scaling, right? So we have 2H2 plus O2 will yield 2H2O. And now I want to get this to 3. I want both of these to get to 3. So what do I have to multiply by? 3/2. I'll do it in a different color as well. I'll write down the enthalpy too, just so that we have that. Negative 488.6 kilojoules per mole. Alrighty. So I'm going to multiply that, and let's see, we're going to do 3 over 2, right? Yes. Yes, 3 over 2, so we can cancel this, cancel that, and we just get left with 3. This is also going to get multiplied by 3 over 2, so I'll just do it kind of like here. So that's going to be 3, and then this will also be 3 over 2. And finally, this will be multiplied by 3 over 2. So then we're going to get 3H2 plus 3 over 2O2 will yield 3H2O. And then the change in enthalpy, oh wow, I really am going to need a calculator for that one. Okay, so you get 488.6. I'm just going to multiply by 1.5, and that'll get us the same answer that we want. So we get negative, oh, that's not a 7. Negative 732.9 kilojoules per mole. Okay, so now what I'm going to do is I'm going to take this equation and this equation. I'm going to compare them, see if I still need to scale things. If not, we're good. We're going to cancel things that we need to, and we're going to get the final answer, and yippee-do. Why did I just say that? Guys, I can't do this. That was so horrible. That was actually horrible. Anyways, I'm gonna get the equation. 3H2. So what I'm doing here is I'm taking the reactants of this one, adding it to the reactants of this one, and then I'm going to do the same thing with the products. Plus 3 over 2O2. And then we're going to add the products together where we have 3H2O and 3 over 2O2. Oh, wait. Just kidding, guys. That's not what I'm going to do. You could do it that way, too. I guess you could. But I meant to do it this way, where we're doing them on top of each other. I got way too distracted by the thing I just said, and I cringed a little too much. So I'm going to take the two things that we just got, I'm going to put them on top of each other. I'm putting them on top of each other so it's easier for me to see. I could have done it the other way and just canceled the things that were on opposite sides, but no, I don't know. So the only thing that we can cancel here is the 3 over 2O2. So that's cool. We're going to say we don't need you and we don't need you because you're on opposite sides. So that's going to give us the equation of just O3 plus 3H2 is going to yield 3H2O. I'm going to check my equation. We have 3H2O. 3, okay. Cool. So that would be our answer for that. So that means we don't have to scale anything, right? So that means that all we have to do is add these two enthalpies together, right? So we're going to do 142.2, negative 142.2, plus a negative 732.9. That'll get us the answer of, so I got negative 875.1, but I feel like I'm messing something up there. Did I scale something wrong? 284.6 divided by 2, 142. Okay, well this should be a 3 apparently, which makes sense. So I don't think that would have messed up the number so much though. 488.6 times 1.5. Okay, so maybe that's all it was. So I'll do 142.3. Unless I did the question wrong the first time, and that's why it's off. Okay, I'm gonna assume that I did the question wrong the first time. But yeah, I got negative 875.2 kilojoules per mole. And that should be our answer there. Okay, so just as a review with this one, so what I did is that we were given one equation and the enthalpy, the other equation and the enthalpy, and what I did was I found out what needed to be flipped first, and if there was anything that needed to be flipped, I determined this one needed to be flipped. I flipped it, did the, I flipped it, and then, so I made that negative. So then I scaled it to get the amount of ozone that I wanted from this equation. And then on the next equation, I did just scaling because I didn't need to flip anything. So I scaled everything to where it needed to be. I checked them both by seeing what would cancel and seeing if we got the result that we wanted. And then from there, I did the enthalpies and I added them together to find the total empathy of the reaction that we wanted. Okay, so sorry for craziness of this video. And thank you all for watching.